Okay, were there any questions about that? Okay, let's do the individual test quiz then. So you can do that now. Okay, let's turn that off. Make sure your score is in, your answer is in rather. Okay, anybody have any questions? Okay, let's continue. Is the stem and leaf display. So let's take a look at that. I noticed actually that we have these data files, so why don't I work with that? So I'll just download this and open that. So here's the data. Now let's go back and check what this was again. So I need to go to here. And this was the number of questions answered correctly on an aptitude test. So here's one person, they answered 112 questions correctly. Here's another person, they answered 72 and 69 and so on. Okay, and this is the entire data set. So let's take a look at that here. So this is the entire data set. So there was one person that was 112, another person that was 73, and so on. So for the next graph that we're going to make, we're going to make another type of graph now. So we've talked about frequencies and cumulative frequencies and dot plots and so on. We talked about various kinds of graphs. There's one more here called a stem and leaf display, or stem and leaf plot. So let's try and make that. So the way that we're going to do that here is first we're going to sort these. So let's sort them. So you can go to Data and Sort. And you can say Sort by Correct and Smallest to Largest. And you want to click this. My data has headers. Otherwise, it's going to include this as one of the data points, but we don't want to include that. That's just the label. So we say my data has headers or labels. So, okay, now we sort it. So we get that. So we have the same data, but it's been sorted. So there's 50 pieces of data because the first first row is the header. So there's 50 pieces of data here. Okay, so now what we can do is we see that the smallest data is in the 60s, and the largest data is in 140s. So we could do something like this, or this is the way we would do this. So we could do 60, 70, 80. So let's do that. And let's copy this down until we get to 140. Okay, so we have that. And now we can take each of the pieces of data in the 60. How do we do this? Okay, now we can take each piece of data that's in the 60s and copy it. And then let me just start it here. I'm going to click here and I'm going to paste it, but you can do something called paste the transpose. So instead of it being copied to this cell and this cell, it's going to be copied in this cell and this cell. So let me do that. So I'm going to paste it, but there's something called this one here, paste the transpose, so we get that. Okay, now I can take the 70s and do the same kind of thing, copy it, start here and paste the transpose, so it goes like that. And then I can take the 80s, do the same thing, copy, paste the transpose, like that, 90s, copy, transpose, like that. Okay, I finished it. So you can see what I did, and you can see the result. Now this is kind of interesting because it's kind of like it's kind of turned sideways, but it's really like a plot. If you don't know what I mean, I could, let's see, I could copy it. Let's see, do that, copy it, and put it on this sheet, but I don't know how to do this actually. Let's see, if I transpose it, what's going to happen? So I'm going to paste and transpose. See what happens. Okay, well, I wanted it to be the reverse. I wanted it to be up. So just to achieve that effect, I'm going to copy it again to another sheet, and I'm going to paste it as an image, which I think, oh, I can't do that. Can't paste as an image, so that doesn't work. Okay, maybe I can do this. It's taking a long time, but let me take a copy, screenshot, and do this, and copy it, and put it on another sheet, and paste it, and I wonder if I can rotate this. Yes, I can rotate it. Okay, so it doesn't look that great, but it's kind of like a histogram now. You can sort of, actually it goes from 60, it goes in the wrong direction. I don't know how I can fix that. But anyway, the point is you can sort of see the distribution here. So you could ask, is it skewed to the right? Is it skewed to the left? Is it symmetric? What does it look like? Now this is all backwards because these numbers are in the wrong direction, but we could go to here and you can see that it's like a histogram, but it's on its side. Okay, so I guess I would say it's fairly symmetric, more or less symmetric. It's not exact, but I would say that it's close to symmetric. Okay, so this is the basic idea of a stem and leaf plot. So these are called the stems here. Usually we put them next to this. So these would be called the stems, and these are the leaves. Now, let's look at, it doesn't look quite like this, like we don't usually have, well, actually we usually do, I think. Anyway, let's look at this in the text. Okay, so let's look at how they show the stem and leaf. So they said they have 150 question aptitude test given to 50 people. So we have 50 pieces of data in here, and then this is how many answers each person got correct. So to make the stem and leaf, so they actually don't say 60, 70, 80, 90. They say 6, so this is read as there's the smallest element apparently was, let's see, 68. Well, 69 and 68. So going back to here, so what they do is they say, oh, well, we found a 69, so we'll put a 6 and a 9 there. Then I guess they said we found a 72, so we'll put a 7 and a 2 here. And they said, well, we found 112, so that would be 112. So that's typically the way it's written, not 60, 70, and so on. So this would be read, there was a 69 there. This would be read, there was a 72 there. So you keep doing that, but then sometimes you'll get more than one. So you get a 6, a 9, and an 8. So then you get this. Mine, I guess, was, I sorted it, so I had a 6, an 8, and then a 9. I guess this is also acceptable. I know they do sort it finally at the end. So you get this kind of picture, which again is kind of like a histogram, but on its side. They pointed out that it's kind of like a histogram on its side like this. It sort of emphasizes that fact. We don't usually put those bars there, but to emphasize the fact that it's kind of a histogram. So they say, although the stem and leaf display may appear to offer the same information as a histogram, it has two primary advantages. The stem and leaf display is easier to construct by hand, I guess, and within a class interval, say 60 to 70, the stem and leaf display provides more information than the histogram because the stem and leaf shows the actual data. So if we just had a histogram, we wouldn't see that this one was composed of 68 and 69. We just say that there was a bar of there was a certain amount of data between 60 and 70. But here we can see exactly what data is between 60 and 70. And then they also point out that if you wanted to, you could split up some of them. So if, like here, we had kind of a lot in 70. So we might want to sort of spread it out. So we would go 70 to 75 and then 75 to 80. So they could do 70 to 70. I guess this is from 70 to less than 75. And this is 75 to less than 80. So you get 72, 73, 73, 75, 76, 76. And then 80, they also split up. So this is from 80 to less than 85. And this is from 85 to less than 90. Okay, so you could split it up like this as well. So they say, if we believe that our original stem and leaf display condensed the data too much, we can easily stretch out the display by using 2 or more stems for each leading digit, like this. Then they say, note that the values 72, 73, 73 have leaves in the 0 through 4 range and are shown in the first stem value. And the values 75, 76, 76, so these have leaves in the 5 through 9 range and are shown in the second stem. And here they point out that you could do, with larger numbers, you can still do this. So preceding example showed a stem and leaf display for data with as many as 3 digits. Stem and leaf displays for data with more than 3 digits are possible. For example, consider this, which is the number of hamburgers sold by a fast food restaurant for each of 15 weeks. So we have this data, and so I guess they're representing 15, 6. This is leaf unit is 10. I guess they're ignoring the 5. And so this would be in the range of 1,560. So you could get one like this. Okay. Okay, so we covered various kinds of this. So let's go back to the groups again. Okay, so there's one more question. So try that one in the groups.
Um, Sensei,
Yes, sir.
could you explain how to find the cumulated frequency on the pulse rate? Because having a little trouble.
Okay, sorry. The accumulated frequency on the what? Oh, on the
pulse rate.
All right.
Yes,
Okay.
on the question we got just now.
Okay.
Right, thank you.
Yes, I can.
Yes, Professor Kloster, if we can just go through all the questions to check our understandings, that'd be very nice. Thank you very much.
Well, I don't want to go through all of them. That's why I always ask, are there any questions? So if you have a question, then I'll go through it, but otherwise I won't. Okay, so if I ask if you have any questions, you can say yes, then we'll go through it. but otherwise, no. Okay, so I'm going to close that one.
Professor, can
Yes.
you just discuss the answers of the of the quiz, the group quiz, or the one before this one, like the second
Okay.
line?
Okay, yes, yes.
I'm just not sure about my
Okay.
answer.
All right, so let's try that. So let me go change this to APU, Manava. Um, okay, how should I do this? Let me do it this way, actually. No, I can't do that. Okay. How can I do this? Okay, I'll share something else. I'll do that. Let's see, I have to stop sharing. And then share. And share the whole thing. Okay. Okay, now I will go to here. So the one before was the, okay, open new window. Here, there. Okay, this one, right?
Yes, sir.
Okay, as a review of an earlier concept, what are the elements of this data set? So this is an important question. So here we can see the data is the number of questions answered correctly on an aptitude test, right? So what are the elements? Can somebody tell us?
The questions on the aptitude test.
The people who took the test.
Okay, so it's not the questions.
The
That's
Number of the
the,
questions.
what?
Number of the
people who took
questions.
this.
No, not the
The
number.
number of
The
correctly
number of
answered
correctly
questions.
answered questions.
No.
The people
What?
who
People
took the
who took the
test.
test.
It's just a test.
What?
The people. The people.
The people. Any other answers?
The number of questions answered.
What?
The number of questions answered.
No.
The
Okay.
test.
So no, it's the people. That's right. So let me explain this because I feel this is very important. So I feel that it's important for you to grasp this, to know this concept. So what can I do here? I'll add a new sheet here, and I'll make it dark. View, color. Okay. And I'll go back to here. And okay, so here's the concept I feel is important. So I ask these questions because of that, because if you understand this concept, it just makes understanding everything more clear later in other parts of statistics. So let's suppose, so the idea is that whenever we're doing statistics, we're talking about variables usually. Variables. So in other words, in this case, the variable was what? I forget already. I think it was the number of questions they got right? Number of questions they got correct, right? Does everyone agree with this? This is the variable?
Yes.
Yes.
Correct. Right. Okay. So, but the thing is, we could have other variables. So what does that mean? What do I mean by that? You can have other variables. So in order to understand that, it's very good, yes. In order to understand that, what do we, so you can see how hard it is to write on this screen. What is the, in order to understand that, you need to know what the elements are. In order for me to say, oh, there are other variables, you need to understand what the elements are. So anyway, does anybody want to try and answer what another variable would be? Not in that question, because there weren't any other variables in that question, but what another variable could be. What?
I'm one of the people who took the test.
I can't hear you. Say it louder.
I'm one of the people who took the test.
Number of people that took the test, is that what you said?
Oh, yeah.
Okay, no, that's not. Okay, let me explain this. I know I've explained it before, but maybe you didn't notice that it was important. So the idea is, uh-oh. Uh-oh. Let me try it again. Something happened. Okay, can you see this now?
Yeah, we can.
Okay, so the idea is that we have an individual. Now, an individual doesn't have to be a person, but it could be a person. It could be, it could be like a school, it could be a light bulb, it could be many things, but we have an individual, and once we have that individual, we can talk about many different variables or attributes of that individual. For example, then this one, the number of correct questions they answered, or their height, or their weight, or their monthly income. Okay, does everyone understand that with an individual we can talk about many attributes? Okay? Is that clear or not? Can you hear me?
Yeah.
Yes,
Yes.
Professor.
Okay.
It's pretty clear.
So now, going back to that question here, so the thing is that the individuals are the people, and this is a variable associated with those individuals. What variable is it? How many answers they got correct on some test. Okay, does everyone understand that? So in our textbook, we went, and in our homework and in our class, we went through several sections that emphasize this concept of elements. So this was a review of that. So here it says there, so what are the elements here again?
A person, an individual.
The students, right? Or the people. Okay? It's not the questions. The number of answers. That's a variable associated with the individuals. Now, as I said, when we use the word individual, you might think it has to be a person, but we use it just as we use that word even when we're not talking about a person. So we might be talking about, like, in school we have these kind of long light bulbs, right? They're a fluorescent light bulb, right? Those could be the individuals. So, and what kinds of things might we be interested in, or attributes might we be interested in about light bulbs? Can anybody suggest anything that we might be interested in? I don't think many people are interested about light bulbs, but if we were, what could we be interested in with regard to light bulbs? What attributes?
How much energy they consume.
Okay, energy.
Consumption.
Something about energy consumption or something like that, right? Okay, something else.
It could be like LED, whether it's LED based bulb or not.
Or not. So that would be called a yes/no variable.
Okay.
Okay, that's good. What else?
How much light they admit?
I think that's the word for that might be lumen.
Yeah, lumen.
Numerical size of the light bulbs.
Oh, Yeah, the length might be, let's say the length, right? So there's lots of things, right, that we could be interested in. So let's just explore this a little bit more. This is a number, right? This is numeric. Does everyone agree with that? The brightness. This is numeric, right?
Yeah.
Energy consumption is also numeric, right? But this is
Yeah.
not numeric. This is yes, no. Is it LED or not? Right?
Yeah.
So we could have numeric variables. We could have yes, no variables. We could have other kinds of categorical variables like the color, right? And so on. Okay? So anyway, the point is we could have many different attributes. Now let's suppose we take a sample. We go to APU. Someday we'll be able to go to APU. And we take a sample. What do? We take a sample of, let's say, 10 bulbs. 10 bulbs. Right? So we have a bulb here and another one, another one, another one. And we have 10 of them, right? And then we say, oh, well, what are we interested in this study? Okay, we're interested in the energy consumption. So that would be the variable. So then from that sample, we would have like 10 numbers, which would be the energy consumption. I have no idea what energy consumption. Let's do the length instead. So we could do the length. So this one would be 30 meters, and this one would be 32 meters, and this one would be 35 meters. I'm sorry, centimeters. And this one would be 25 centimeters, right? So we'd get a bunch of numbers there, and that's what we got in this question. We got a bunch of numbers here, right? Does everyone understand? But these numbers were from individuals. The individuals in this case were not light bulbs, though. They were what? People. I guess students or something. Anyway, they were people, right? Does everyone understand?
Yeah.
So, finally, what are the elements in this data set? So, are they the questions? No. The questions were something else. The number of questions answered on the aptitude test? No. The test? No. The people who took the test? Yes. Okay, does everyone get it now?
Mhm.
So these are an attribute of each of the individuals that took the test, each of the people that took the test. Okay, let's go on. What is the variable being measured here? So what's the variable being measured?
Pretty
Here.
obvious it's that correct answered questions.
The number of questions, oh, sorry, this is it, you're right. This one, the number of correctly answered questions, right?
Yeah.
Okay, good. And as a review, what is the measurement scale for this question, for this variable? So is it nominal, ordinal, interval, ratio, or none of the above? So the number of correctly answered questions, what kind of variable is that?
Ordinal, maybe?
No. Is there a
If it's-
zero? Is there such a thing as zero?
No.
No?
No.
Really? It's impossible for someone to answer no questions correctly?
Oh yes, it's very possible.
Right, it's very possible. So if there's a zero, and if zero has meaning, that means that we can consider the ratio. For example, if one person did 100 correct and somebody else did 50 correct, can I say that one person did twice as well as the other person?
You can.
Yeah,
Yeah.
that means ratio. Right?
Hmm.
Right? So this is, you might think this is like some abstract BS that's not important, but unfortunately your teacher doesn't agree with you. So you have to learn it. Okay, I think that it's really important. I found in my own experience that it's really important. More important than most other things. So you have to get this right, at least in this class. All right, any questions about that? Okay.
I want to sneeze.
What? Hello? Okay. All right, let's go on to the other one then.
So what was the correct answer? Ordinal?
For what?
Like for the last question.
Ratio.
Ratio. Okay.
Okay, now let's go to the other one. So I'm going to ask you that question until everyone gets it right. Those questions. Okay, how about this one? Suppose we have the above stem and leaf display. How many times was the pulse rate below 80? So,
Is it a screen?
okay,
Screen still of the blackboard.
you can't see my screen?
Yeah, we can't.
Okay, sorry about that. Let me go back to here and try it again. Can you see it now?
Yeah.
Yes.
Okay, let's read it again. So this is pulse rate. Let's just understand what this is. So this is a pulse rate stem and leaf display. That's what's called, stem and leaf display. So what does this 8 mean? First of all, what is pulse, by the way? What is pulse?
A person heartbeat.
Yeah, it's something about our heartbeat, right? Okay. So okay, so what does this 8 mean?
68.
Means 68, right? So 68 beats per second or something like that, right? Right. And what does this 9 mean?
69.
69. And what does this 4 mean?
104.
104. Okay, so by the way, what's a healthy heartbeat? Anybody know? I don't know the answer. What?
96.
96? Okay. Okay, so this person is healthy. And this person is dying. And this person is going to die soon. Okay, no, we don't know, right? I don't know the answer to that. But anyway, so does everyone understand this? So which category has the most elements in it?
70.
70, right? There's a 70, 71, 71, 74, 76, 76, 78. So that's 1, 2, 3, 4, 5, 6, 7. Now, did I use that word elements properly? I just said, which category has the most elements? Did I use that word correctly? What does what are the elements in this data?
The people.
The people. And this is a variable associated with each person, right? The variable is what? Their pulse rate.
Pulse rate.
Right? Their pulse rate, right? Each person has a pulse rate, right?
Yeah.
Oh, that's what we have here. Okay, does everyone understand this picture, this diagram?
Yeah, we do.
Yeah.
Now, if you could rotate it 90 degrees counterclockwise, it would look like a histogram, right?
Yeah.
Yeah.
So that's the advantage of doing this. You kind of get a picture of the spread of this data. So what word might you use to describe the spread of this data? We have some words to describe spread. So what word might you use to describe the spread of this? So you have to rotate it counterclockwise 90 degrees. And then what word might you use to describe the spread?
Histogram?
The spread of this histogram or the spread of this distribution, what word would you use?
It's rightly skewed.
Okay, yeah. I'd say that it's kind of skewed to the right. Now, maybe you don't agree. Maybe you'd say it's kind of, what's the word, symmetric, right? You might say it's symmetric, but I think it's pretty easily argued that it's skewed to the right a little bit. Okay. So that's just interesting. But the point is that when you make this stem and leaf display, you can make statements like that. You can talk about the shape of the distribution just by doing the stem and leaf display. Okay, does everyone get this? Okay, so next they say, and I mean in the question they say, suppose we have the above stem and leaf display. How many times was the pulse rate below 80? So how do you figure that out? You just count the number of elements in the 6 and the 7 categories, right?
Yeah.
So that's 4 and I think we said 7. 4 and 7. So the answer is 11. Okay? Everyone understand that?
Yeah.
Yeah.
And the next one is, if we have the above display, what is the cumulative frequency for less than or equal to 80? So it's the same answer as this one. It's 11. Okay, it's the same meaning as this one. Okay? The cumulative frequency just means you accumulate how many are below 80. So that's obviously what we just answered, 11. All right, is that clear?
Yes.
It just means you add up. That's what cumulative means, accumulate. Okay, all right, so let's go on to here. And let's go to the next video, which is conclude. Anyway, let's go here. Displays of the data. We talked about frequency distributions and cumulative frequency distribution. Can everybody hear this?
Yep.
Yes.
Okay. We covered various kinds of displays of the data. We talked about frequency distributions and cumulative frequency distributions and dot plot, and now stem and leaf. Let's just quickly review. They have down at the bottom a bar chart and a histogram are essentially the same thing. Both are graphical representations of the data in a frequency distribution. A histogram is just a bar chart with no separation between the bars. For some discrete quantitative data, discrete quantitative data, a separation between bars is also appropriate. Consider, for example, the number of classes in which a college student is enrolled. The data may only assume integer values, right? You can't be enrolled for 1.5 classes or 2.73 classes. Those are not possible. With continuous quantitative data, however, such as audit times, a separation between bars is not appropriate. So they're saying that when you're doing a bar chart instead of a histogram, sometimes you want to have separation between the bars, but sometimes you don't. So if it's discrete data, maybe you should have separation between the bars. But if it's not discrete data, if it's continuous data, then maybe you don't want to have separation. Okay, let's skip down to this one. So they said open-end class requires only a lower class limit or an upper class limit. So what they're talking about is, suppose we had some observations and the last equals 100. Let's go on to the next one. Okay, let's take a look at chapter 3, which is called Descriptive Statistics, Numerical Measures. So let's see what's in chapter 3. So some of these are probably familiar to you. For example, the mean and maybe the median. We'll cover all of this. So let's take a look at that now. So these are all in chapter 1, they're all called measures of location. I prefer to call it measures of center. Measures of. Okay, so I should have said most of these are called could be called measures of center, but the percentile percentiles are not measures of center, they're measures of location, and they're also included in here. But most of these, like the mean and the median, tell you where the center of the data is. Of the center of data. So let's see, for example. So for example, we have this data here. We might say, well, what's the mean of this data? And it's very obvious how to compute it. For example, suppose we have this data and you want to compute the mean. So let me just line this up in a different way. So remember, you can copy something like this, and then you can paste it by doing what's called the transpose, this one here, and you get that. So we have these numbers, and we want to know what the mean is, and I think everybody knows how to do that, but I'll just write it here. I'm going to practice using this board that I have. Okay, I'm going to try this, but I'm really not very good at this, but let's see if I can do it. So, of course, we know what to do, though. It's just 5. Oh, that didn't work. So 5 plus 6 plus 7 plus 10 plus 11 plus 12. And then, of course, we just have to divide that. I told you I'm not good at this. By the number of elements, which is 6. Oops, that didn't work either. 6. Okay, so I think that that's going to be, you can see that this is centered at 7, 8, 9, 10. I guess it's centered at 9.5 maybe. So it might be 9.5. Oh no, that was obviously a mistake. It's not centered at 9.5. It's centered at what? So you have, this is basically balanced. You have 5, 6, 7. You have 10, 11, 12. So where's the mean going to be? Right between 7 and 10. How big is the interval between 7 and 10? How big is the interval between 7 and 10?
8.5.
The interval between 7 and 10 is 3, right?
Yes.
Yeah.
So half of 3 is what?
1.5.
1.5.
1.5. So it's going to be 7 plus 1.5. It's going to be 8.5, not 9.5. That was
But how come it's 9.5?
stupid. But anyway, I'm not sure about that actually, but it might be 8. What is it? 7, 8, 9, 10. Maybe it's 8.5 actually. So whatever it is, that's what we mean by the mean. And the symbol we use for the mean is that symbol, x bar, or later on we'll also be using a Greek letter, mu. So we'll see that later, but sometimes we'll use x bar, sometimes we'll use mu. Okay, so that is what is meant by the mean. Now also, suppose we have another set of numbers, let's say, or let's, suppose we have the numbers 5, 7, 9, and 11. Okay, so again, if we want to calculate the mean of these numbers, we'll divide by 4 this time. And I think here we can see that the answer is going to be 8. It's right in the middle. Okay. Now there's another measure that we're going to look at called them. Well, actually, before I do that, usually we'll denote the first element of our data set as x1. So in this case here, the first one is x1 is 5. We'll denote the second element by x2. So in this case, the second element is 7. We'll denote the x3 will be 9, and x4 will be 11. So we could say that 11. So we could say that the mean is, instead of 5 plus 7 plus 9 plus 11, we could say it's x1 plus x2 plus x3 plus x4 over 4 in this case, because there are 4 elements. And if suppose we had 7 elements, then it would be x1 plus x2 plus, and we keep going up to x7, and then we would then we would divide that by 7. That would be the mean. And suppose that we had, of course, if we had 10 elements, it would be x1 plus, how do I erase this? Let's see if I can do this. Okay, x1 plus, and we'd go all the way up to x10, and then, of course, we divide by 10. So if we want to be general about it, we'd say it would be x1 plus, we'd go all the way up to xn, and then, of course, we would just divide by n. So this is the general formula for x bar. Okay, let's try introduce or review another notation, which is called the sigma notation. And let me ask you, I think everybody might, maybe you don't know it, but you might know some Greek letters. For example, you might know the way, you might know the Greek letter for A. You might know that it's alpha. You might know that the Greek letter for B is beta. I think this one is a small alpha, but this could be a capital beta. So just like in the Roman alphabet or the English alphabet, we have capital A and small a. They also have capital alpha and small alpha. I think the capital A might be this, just like that. Right? Maybe the capital beta is the same as the small beta, but just written in a bigger way. Do we know any other Greek letters? I think we know delta. We know the D, rather. We know D, the capital D at least, is delta. So we use that sometimes. We write like delta Y over delta X. Whoops, I don't know what happened there, but anyway, you know what I'm talking about. And so what else? Do we know any others? I'm sure that some of you know some others. I can't think of any right now. Well, maybe anybody know any other Greek letters?
Gamma.
Gamma, okay. Yeah. Any others?
Sigma.
Sigma, okay. Any others?
Omega.
Okay, so there's
Iota.
Yeah, right.
Epsilon.
Okay, enough. Yeah, we know a lot, actually, you're right. Maybe you know theta. Theta. I don't know, is that a T maybe? That's not a T, actually. But anyway, maybe that's not quite the same. There's nothing quite like that in the English alphabet. Anyway, we know some Greek letters. Now, it so happens that, in mathematics, we use some Greek letters, and that's just to distinguish them so that you don't sort of think that it's just like a sentence or something. So instead of using A, which might be part of a sentence, you might use alpha. Then it's not part of a sentence. It's some special symbol. So we sometimes use symbols like that. And I think you also know the Greek for S. Now, maybe you know it. You might, everyone's probably seen this. And that is a Greek S. We call it sigma, but it's a Greek S. So if you wanted to spell let's say, I don't know what word begins with S. Anyway, you could write this, I guess, S-A-B. I don't know what stab. But anyway, this is an S, this is an A, and this is a B. Now, we know that S, or that sigma rather, because you probably know that we use it something like this. You might have some problem with this, but you probably know that we use it like this. And the reason that we use that Greek S is because it's... Why do we use sigma? Why don't we use gamma here, or delta, or alpha, or why do they use sigma here? Alpha, beta, gamma, theta. We could have chosen all kinds of letters. Why did they use sigma here? Okay, let's see why.
Because S means sum.
Yeah, that's right. Word sum. Sum means another word for addition. So sum and addition basically are the same thing. And so for when we're doing addition, we use the Greek letter S because it's like the first letter of the word sum. Okay, so how do we actually use this? So for example, suppose I wrote, sometimes you might see it like this. You might see I squared, and you might see I goes from 1 to 4. Sometimes we'll write the I up here, and sometimes we leave it out just because we're lazy. We might just say I goes from 1 to 4 without this I up here. Sometimes we might just leave out the I altogether if we're super lazy. Okay, so anyway, what does this mean? So let's just review what it means. So all it means is that you put you put I equals 1 into here, then you put I equals 2, then you put I equals 3, then you put I equals 4, and you stop there because this is the last one. What do I mean by you put I equals 1 in there? What do I mean by you put I equals 2 in there, and so on? So I just mean you write 1, and then you have to write square because it says I squared. And then you put I equals 2 in there, so you write 2, and then you have to put the square there because it says I squared. And then you write 3, and then it says square, so you have to put the square. And then the last one, we said we're going to stop at this one, and you do that. So you just write that, and then what does the sigma stand for? So we said the sigma is an S, and it stands for this, for sum. So what does that mean? It means what do we put in between here? We put a plus. So you put a plus there, and a plus there. So that's what this means. It means this. So that's, if I do that, what do I get? I get 1 plus 4 plus 9 plus 16. What is that? 1 plus 4 is 5, plus 9 is 14, plus 16 is that 30? Is that right? Let's try it again. 1 plus 4 is 5, plus 9 is 14. Yeah, 30. Okay, so you get 30. So what is this equal to? It's equal to 30. Okay, let's try another one. But first, let's stop. Okay, let's try another sigma with a different color. Let's try sigma x plus 5 squared, and I now goes from 1 to 3. Let's make it a little bit shorter this time. So what is this? I think I correct this later, but I made a mistake there. This either has to be I instead of X, or this has to be X instead of I. I was asleep at the wheel. So first we put in I equals 1. Oh, I'm sorry, it should be, I guess I should say X. Sorry. X equals 1 to 3, not I equals 1 to 3. So first we put in X equals 1, so we get 1 plus 5. I just put in 1 for X, and I square it. And then I do the next one. I put in I increment X here. X is 1, then I let X go to the next integer. So X becomes 2. So I write 2 plus 5, just like it has here, 2 plus 5, and then have to write the square. And then I write 3 plus 5 and square. And then what? Well, what does the sigma mean? It means you add these terms up. So you get this, and whatever this equals, I mean, this is equal to 6 squared, and this is equal to 7 squared, and this is equal to 8 squared. So whatever that is, it's 36 plus 49 plus 64. I'll let you do that, but that's what this is. Okay, let's do another one. Let's say I equals 1, I'll just keep it short again, 3, and let's say one more here. Let's just say I plus, or let me just say 5i. Okay, so 5i. So I put in I equals 1, so I get 5 times 1. Then I put in I equals 2, so I get 5 times 2. And then I put in I equals 3, and I get 5 times 3, and we just add these up. And so we get 5 plus 10 plus 15, which is 30, right? Okay. Now, I said that sigma is the Greek S. Now, can you, there's another Greek letter that we know that I forgot to mention, and that is this letter. We know that as pi. So, of course, we know that pi is a number, usually represents a number, but here it's a different story. So can you guess what pi stands for? Well, suppose I said this, pi, what did I have at the beginning? I squared. So let me do pi I squared. And suppose I say I equals 1 to 3. Actually, I don't want to do this. Let me do a different one. Pi, I had another one up here. Let's do that one. X plus 5, and I'll leave out the square this time just because I don't want to make it so complicated. So I'll just say I equals 1 to 3.
2.
So can you guess what this means?
What did I do wrong there? What did I do wrong here? If I have, yeah, either I need I here, or I have to change this to X. Maybe I'll change that. Let's see.
Means. So it doesn't mean, it's not sigma. Sigma means add them up. Can you guess what this stands for? So,
okay, so let me just fix that. Let me do it here. So suppose I had this pi I plus 5, and I goes from 1 to 3. Can anyone guess what this means? But if I ask you this, you know what it means, right? Right? If I ask you this, you know what it means, right? Right? Everyone knows that, right? What does this mean? First, I put in 1, so I get 1 plus 5. You know what this means. 1 plus 5 plus 2 plus 5 plus 3 plus 5, right? Everyone knows that. But what does this mean? So you know what sigma means, right? Sigma is a Greek letter. Which Greek letter?
S.
S. And what are we talking about? Why are we talking about S?
Sum.
The sum, right? Okay. Pi is what Greek letter do you think? Any guess?
P.
Pi is a P. Okay? Pi is a Greek P. So what do you think this means in this context?
Product?
Yeah, product. So if this means sigma, means you put pluses in between, then what's this going to mean?
Times.
You're going to put times in between. So if I do it down here, what am I going to get? Again, I start with I equals 1, so I put 1. Sorry. I put 1 plus 5. Then I do what? I equals 2, so I get 2 plus 5. Then I do I equals 3, I get 3 plus 5, right? But now I don't have sigma, so I'm not adding them, right? So what am I doing?
I'm multiplying.
Yeah. Okay. So this one means this. Okay, so everyone get that idea? So there, let's see, we did the product, and yeah, like this, and you get that. Okay, does everyone understand this? So if you have pi, it means multiply. If you have sigma, it means add. And we don't use pi very often in most classes, but in other math classes, you do use it sometimes. Okay, everyone okay? Okay, let's take a quiz now. So let's go to the groups. Okay, let's go to the groups. Let's see. And it's going to be again on Manava. Okay. So what's the answer to this one?
Second option.
Second. One word for addition in English is sum, which starts with an S, and the Greek S is sigma. So that's why. Okay. Let's do an individual one. Oh, sorry. Oops. Why did I do that? Okay, sorry. We have to go back to the rooms again. I'm sorry. Let's go back. Sorry about that. Okay, so actually there's supposed to be a little mistake here. This is supposed to look like this instead of what it looks like right there. Supposed to look like this. So it's supposed to be I equals 1 to I equals 3. But anyway, what is this equal to?
3 plus 6 plus 9.
Yeah, so it's not 1 plus 2 plus 3, and it's not I plus 2I plus 3I. It's when I equals 1, you get 3 times 1, so that's 3. When I equals 2, you get 3 times 2, so that's 6, and then you get 9. Okay, let's have one more with just individual. Let's try that. We'll try that one now.
Is this I also applies to one racer?
Sorry?
This I means one, the previous one, right?
Yeah, that's right. Sorry, I don't know why it looks like that, but it should look like this. Thank you. Yeah, this is the question. This equals what? Okay, I'm going to close it in 15 seconds. Okay. Okay, so what's the answer to this? Well, we just figured out that this
18.
means 3 times 1 plus 3 times 2 plus 3 times 3. So it's just a question of adding that up. 3 plus 6 plus 9. Okay, so that's 15 and 18. Okay. Okay, I think that's all we have time for now. Next time we'll be working with population and samples, and then we'll be talking about the mean and the median, and maybe the mode, and we'll see what after that. Okay, so we will see you next week, and I will add a short assignment, and I will adjust the homework for what's due in WebAssign. So don't get started on it. I mean, you can do, but we have right now, it currently says we have a lot of homework, but it won't be all of that homework. Okay, that's all for today.
Excuse me, Professor.
Yes.
I have the problem with the Khan Academy, so I already sent an email to TA. So
okay, good.
Yes, but like the TA said that like I would like ask you the problem. Yes.
Okay. Okay,
So,
everybody, you can leave or you can stick around. So you want, which problem is it in Khan Academy?
Yes, so I already done, finished all the last week homework. Like yesterday, when I like check the Khan Academy again, I suddenly see it like only half of my homework was submitted, while the other half on like it was not submitted. So, and it's due already, so I couldn't do anything. So can you please check my account or something?
Okay, somebody was talking while you were talking, so I didn't quite hear what you said, but I'll look at your name. So let's see, what's your name again?
My name is Long, Long.
L-O-N-G.
Yes.
Okay, but it's not spelled. It's not. That's not how it's written in your for your first name. What's your other names?
Can I type on the chat?
Okay. Well, no, I can see, but I just have to choose what it is. Where did you go? Now I can't see you anymore. Oh, there you are. It might be Nguyen.
Professor, I just like text my APU account, which I use in Wi-Fi sign. I know, like Khan Academy.
Wait, you're Nguyen Hyung?
Nguyen Hong?
Yeah, is that you?
I don't think so. I'm Nguyen Thanh Long, so.
But I don't see a long there. But wait, Nguyen Tong. Nguyen Hyung. What about Tong? Oh, yeah. Okay. Your name is somehow shows up as your email. Okay.
Yes.
Okay. So let's see. You don't have some of the answers are not there, right?
Yes.
Okay. So what's your situation?
So my situation was that like I finished all the like assignment on Khan Academy 3 days ago.
Yeah.
But like yesterday, because like I had to do like the homework on web science, so I gotta check the video again for like homework. But like I suddenly saw that like half of my homework was undone.
Okay, say it one more time. The screen got messed up. Sorry, say it one more time.
Can I like maybe can I like send the message to you? Like
just say it again because the screen got mixed up and I couldn't concentrate.
Yes, so like 3 days ago, I finished all my homework.
Yeah.
And then like yesterday, I checked it again. I suddenly saw that like half of my homework undone on Khan Academy.
So you finished it, but it didn't show up as finished.
Only half of them. Only half like was undone. Yes.
But you don't know why, right?
Yes, I don't know why.
Huh. I don't know why either. So let's see. Let me see. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 8, 9, 10. Oh, I see. Some of them show 0 time, but I don't see. So, were there any quizzes in that homework? I don't see any.
Yes, there were.
So like some homework, I see like the questions separately and some are like videos.
Okay. Maybe we have to talk later because I have another class.
Professor,
So,
can I ask a quick question?
Yes.
So approximately what time are you going to adjust our homework?
Today, maybe around 5 or 6 o'clock, but let me just look at it right now. Let's see. Right now we have 6:16. So, yeah, I have to get rid of several of those.
Okay. Okay. So around 5 or 6.
Yeah, 6 o'clock maybe, by 6 o'clock.
Thank you very much, Professor.
Okay, I have to go now because I have to open up the class for the other students. So what you, Mr. Long, should do is we should share a screen together, but maybe, are you available at what time? About 4:30?
Sorry, today?
Yeah.
Yes, I'm thinking I'm available 4:30.
Okay, so send me an email and I will send you an invitation and we can share your screen and see what's going on.
Yes, thank you so much.
So you have my email, right?
Yes, I know your email.
Okay. Okay, thank you.
Thank you so much, Professor.
Welcome.
Sorry, Professor, but like on 4:30, like I will see you on this class.
I'll send you a Zoom invitation.
Thank you so much.
Okay. Thank you. Goodbye, everybody.
See you. Yes.